Next is theorem. If both of complex function and its Hermitian conjugate are then complex function will be stationary or constant, because both real and imaginary parts will be stationary. Okay, mean they're real and imaginary. They're the simplest theorem. So, we know that function of C is actually the let me write in this form. Okay. Alpha beta, but alpha and beta where both, as I already explained, that both function will be a real, but axis will be defined that it is imaginary part, but actually R and I are both are a real. Okay, so that means here. I have applied, if you have A plus iota B, that will be A dagger minus iota B dagger. Okay, so in this way, I have applied the I have applied the Hermitian conjugate on both, and that will be okay. Got it? Next. That is not matter, so transpose will be not effect on it. No, you are wrong. One minute, please. If you have a matrix and you take a complex conjugate A, B, and C, you will apply on a complex conjugate. It will apply on a matrix. They will go to the complex conjugate of every element. Okay. Similarly, when you take the Hermitian conjugate on the, or because this is not matter to make consider that these are a complex conjugate. Okay. Similarly, if you are taking the complex conjugate of C, that will be equal to RC plus iota I. That will be equal to R alpha beta plus iota I alpha beta. Yes. Okay. These numbers are real numbers. So I missed this step. Okay. That will be a straightforward for you. That's why. But I don't know. Okay, I have to do it again. So that's why I have write it, and then that will be. So here will be a minus in this. Okay. So this will be. Okay. And this is if I say that this is equation X, and if I say this is equation Y. Got it? Okay. May I erase it? Okay. So from equation X, since FC and F both are that is given. If both are analytic, if both are analytic, then that will be a constant. Okay, both are analytic. That is given. Yes. If they are analytic, then that will be satisfy the Cauchy-Riemannian conditions. So X implies that, yes, what is X? X will be implies that we have to prove that are stationary. That is the result. That must be a result. Partial R over alpha, that will be equal to partial I over partial beta 1 equation X1 partial R over partial beta, that will be minus partial alpha. This is equation X2. Okay. This is Cauchy. Cauchy-Riemannian condition. Okay. So according to Cauchy-Riemannian conditions, this will be a result. Similarly, Y will also satisfy this because they are these are also analytic functions. So when we apply this, may write in this way. Yes, that may be right in this way, minus maybe. Okay. So now this will be your I prime. Yes. Okay. So according to this formula, R over alpha will be equal to partial I prime over partial beta. 1 minute. Partial I prime. This is I prime. Yes. This is I prime. So Actually, this is I prime is equal to minus I. Okay. This will be a y1. Okay. And partial r over partial beta will be equal to yes minus partial I prime over partial alpha equal to minus I over partial alpha. So partial r over partial beta will be equal to plus partial I over partial alpha. This will be a y2. This will be y1 and this will be a y2. Okay. Yes. This I prime, that was I prime, a minus I. Yes. I prime is equal to minus I, so that will be from equation y. Okay. So this will be equal to this. Okay. Okay. I over beta. Okay. Putting value of I over beta in equation from y1 and y2. See. Okay. From x1 and y1. Okay. If we put this value, this will be equal to partial r over partial alpha is equal to minus partial r over partial alpha, because this will be equal to this in reverse case. Or you may put here, or you may put here. Okay. Partial I over partial beta is equal to minus partial r over alpha. So this will be equal to minus r over alpha. Okay. Okay. And you may write this will be a 2 partial r over partial alpha. When it shifted to left, that will be add, and this will be a 0. Partial r over partial alpha will be a 0. This implies that this implies that this is a constant. Okay. Yes. Similarly, y2 and x2 and y2 implies that partial r over in this case now we have to consider the iota part. Okay. So okay. Okay. Similarly, partial I over partial beta is equal to minus partial I over partial beta to and instead I think 1 minute. 1 minute. partial R over partial alpha must be equal to 0. Okay, 1 minute. Partial R over partial alpha is 0. Okay. 1 minute. Okay. This is Z1. Okay. Okay. And partial R over partial beta. When you consider it, that means if we consider partial R over partial beta from equation x2 and y2, okay, partial R over partial beta will be equal to minus partial R over partial beta, and again partial R over partial beta will be equal to 0. Okay. Okay. I say that this is Z2 equation. This implies that derivative of R will be partial R over partial alpha plus partial R zero, and this implies that R is constant. Okay, total derivative is 0, so there that will be a constant. Achha, what was the problem? If I consider that, then if we take the partial derivative with respect to alpha, this will be a constant. That will be constant with respect to, if I integrate here, okay, actually, no, what is her name? She is right. Actually, when you integrate, this will be R constant C, okay? But this constant doesn't mean that is constant with respect to beta 2. There may be a variable of B. This is not complete constant. This will be constant with respect to C only alpha. Means here alpha is cut, but beta will be not. It will be constant. It is a very important to note. If I integrate it with respect to alpha, then that will be constant with respect to alpha, but not constant with respect to beta. In this case, it is constant with respect to alpha as well as the beta. Okay. Similarly, we may prove that I dash is 0 implies that I is constant. Okay. You may say that this is result 1 and this is this is result 1 and this is result 2. From result 1 and 2, R1 and result 2, we have R constant and R is constant with respect to both beta, and I is also, if I say this is, means they constant may be a different, so I must write C1 and C2. They are not equal, they are constant. I have not stated that they are equal. So they are constant with respect to alpha and beta both. Okay. Okay. Again, remember it that if you integrate it, it will be constant, but it will be constant only with respect to alpha. But if I integrate it, it will be also a constant, but it will be constant respect to only beta. So if we combine both results, then that will be constant with respect to alpha as well as the beta. Okay, got it. There are different way to write. Some people write as slash, and some people write in this way too. You may write in this way. C1 is function of alpha naught, beta naught, and I is also function of alpha naught and beta naught. Mean the value is fixed. What was the initial value, that will remain the always initial value. Okay, that will be not changed. There are two ways to write the constants. Okay, got it. But here again, here will be in multiple question or in short question, it may be asked in exam, what is the meaning of this? You have to explain that this meaning is alpha constant, and this meaning is this meaning will be R is constant with respect to beta. This will be, say, the constant with respect to beta, but alpha will be not constant. Okay, and with this means that it will be constant with respect to alpha. This usually come in the short type of question. So, okay. Next theorem is about